Good day all. Today we'll be looking at another question under commutation. Our question says a 4-pole wave 1 DC machine running at 1500 RPM has a commutator of 30 segments, 30 centimeter diameter. If armature current is 150 ampere, thickness of brush is 1.2 centimeter, and the self-inductance of each armature coil is 0.07 millihenry. Calculate the average EMF induced in each coil during commutation. Assume linear commutation. Now we are told what wave 1, so let us also always watch out for those phrases. So our A is what? 2. Now we are asked to get what we're looking for here is our reactance voltage. It is as a result of self-inductance as current passes through your armature. Now this delays your time of commutation. So for us to find this reactance voltage, we have this to be L di dt. That's the formula for reactance voltage. But in this case, we'll be using L times 2I over Tc times your what? A. Now your Tc, which is your time of commutation, is given as Wb minus Wm, which is the width of your brush minus the width of your mica insulation, which wasn't given, over your peripheral velocity. Now your brush width or thickness was given to be 1.25. So the issue now lies in getting our what? Peripheral velocity. Now, like I said in one of my videos, I will still repeat that again. For us to get our V or our peripheral velocity, we have to convert this first, this value of n, our speed, we have to convert it in terms of what? ROPS, that is revolution per seconds. So if we do that, we have 1500 will be dividing it by what? 60. This we're dividing by 60 because we're converting minutes into what? Seconds. So this, now when you divide this, you have that your answer is what? 25. Yeah, 25 ROPS. Now we want to express it in terms of centimeter per second because of our width. Our brush width is what? In centimeter. So we want to express it in what? Centimeter per what? Second. So we are looking for a value that will replace how to replace our revolution. So a complete revolution can also serve as the circumference of your commutator, and circumference of your commutator we're only given our what? Diameter. So we can get that circumference is given as 2 pi r. In this case we are given d, and we know that r is half of d. This cancels out this, and we are left with what? Pi d, which in this case is what? 30 pi. So multiplying this circumference of your commutator to your ROPS, you have that your V is equal to your 30 pi times 25, and this will give us approximately 2356.2 centimeter per seconds. Centimeter per second, which is what we want to express our peripheral velocity as. So replacing that here, replacing the output, imputing our values, we have our WB to be 1.25 minus that of our mica, which wasn't given, so we can say minus 0 because it's negligible, and over our V, which is what, 2356.2. Imputing this to your calculator, you have 1.25 over 2356.2, and this gives us approximately 0.53 milliseconds. That's the value of our TC. So we will come over here and impute our values to get our reactance voltage. We have our L to be what, 0.07. This milli times 10 raised to power what, minus 3. We'll multiply it by 2 times of what, your current, which is what, 150. Then your TC, which is 0.53, we multiply by 10 raised to power minus 3, and we multiply it by your what, A, which is what, 2. Our A is what, 2. So imputing this in your calculator, we have that our reactance voltage is what, 19.81 volts. So this is our answer. So we are this is our answer. And for the case, if you are wondering what assume linear commutation meant, this is the formula. Another form they can ask you is assume what sinusoidal was commutation. If that is being asked, then you simply multiply this by 1.11. Adjust the difference. But since it's linear, we will be multiplying it by this. So thank you and God bless you. I hope this was helpful. Please subscribe to the channel and see you in the next video. Bye.